So Moore state machine is another one type of FSM that we are going to discuss today. So last class we have clearly discussed in Mealy system what will happen is that the input will clearly affect the output. So here let us design a system so how that is different from the Mealy. So let us take three states. So which is similar to that, everything will be similar but representation will be quite different. So here is A. So when the input is 0, it will stay in the same state. So here we won't put a bar and present output. So instead we will add that inside. So here that output will be taken in as inside. So this will come here. So whenever the input which is equal to 1, this will be changed to the state B and output will be represented as 1. So whenever there is an input which is 0, so that is represented here. So when the input which is equal to 1, so this will be changing to C state and output which is equal to 0. So when the input is 1, it will be going to A state. When the input is 0, it will be going to A state. Okay, so this is how things we will be taking. So this will not be that much complicated. So similar to that. So here A will be represented as 0 0 and B will be represented as 0 1 and C will be represented as 1 0. So the X state which is 1 1. Okay, so this will be QB and this will be QA, so as we know. So the output will be what means, so when it is in A state the output will be 0, when it is in B state output will be 1, when it is going to C state output will be 0 and it will be X. So here the output, how the output can be derived is a, so simple came up for this one, so this one, so QB bar and QA. So that's all. So only this one representation will be fine. So this is how we will be doing. So that we have find out the Z with a large scale, right? So that all are not needed. So simply we can use these levels and we can find out. So this is how Moore state machine that will be working. So to the things. So in Mealy machine we have see there are plenty of things, just like we have to analyze everything like that way. But here we can directly do our substitution and this much complex is not needed. So we can clearly, so we can use the same method to find out the things, but here that is not needed. So usually they will ask us to find out this output only. So that thing we can directly find out with the help of these things. So just a state representation and particular output. So from where we will be comparing the comparison between output and input. So let's see one of the important question that is asked in one of the competitive exams. So the state transition diagram for the bureau logic is, so they are given on logic and they are asking us what will be the state transition diagram for this. So here we know that this is an mux and this is a demux. So both are coupled together. So let us first draw the equation, characteristic equation or the output equation for the mux. So the selection line was A. So when the A bar, when the it is 0, then Q will be selected. So that will be Q bar, Q. Okay. So that will be Q. Here it is X0. So the below one, so that is Q0 will be selected. So when A is 1, the X1, Q is selected. So when A is 1, the X is selected. Okay. So this is what the output equation. So when A which is equal to 0, what will happen? Y will be equal to Q bar. So Y will be Q bar means then D. So D is opposite. So that is D bar. Okay. So when A which is equal to 1, the output Y which is equal to Q. So Q means that is straight as D. Okay. So this is understood, right? So this is because the D is directly coming here. So that's why I mentioned like this. So here we could clearly see whenever A is equal to 0, there is a state transition is happening. So it will be D, but output will be D naught. Whenever A is equal to 1, the output will be D. Okay. So let us try to represent this in a simple term. So here let's take two state. So here there is only two state. That is, one will be Q is equal to 1, Q is equal to 0. So here let's take Q is equal to 0 and Q is equal to 1. Okay, these is two state. So A is the selection line, so that is a trigger. So whenever A is equal to 0, there is a change in state will happen. So whenever A will be 0, there will be change in state. So when A is equal to 0, there will be change in state will happen. So whenever A is 1, that will read in the same state. So whenever A is 1, that will be in the same state. So whenever A is equal to 1. So this is how the simple state transition can be represented for this logic. So here, from here we can directly say, we can name anything. So maybe S0 or S1, any kind of naming we can do. So for now I am leaving this as a Q0 and Q1. Q is equal to 0 and Q is equal to 1. Okay. So this is how the things will work. So any kind of representation can be done like this way only. So I hope you guys are able to get some point here. So how we can understand the Mealy and Moore system here. So this is what the quite small introduction on the FSM. So this much thing is needed. this much thing is foreign enough for us to get into any kind of examination. So mostly in more Mealy system, what they will ask is that they will ask us to analyze the Mealy state machine output. So that thing we can easily do with the help of this one. And more system also they mostly ask these ones only. So next class we will be seeing about the sequence detector. So that is one important question. So where will be some possibility for asking any competitive exam. So for now, please try to understand this logic, and if you guys have any doubt, please post in the comment section. Like, share and subscribe our channel, and stay tuned for more videos like this.